We've talked about preamps many times in the past, and I think most of you know by now that I don't generally like preamps with tone controls. Now, it's not that I object to tone controls in principle, because I don't, but I found that most of them add so much colour to the sound, plus all the other things like phase shift. Some of them add horrendous amounts of phase shift, and of course that just muddles the image, but we don't want to go over old ground again. But if you remember several videos ago, in fact getting on for about 8 months ago, I had a kit which I built, and I didn't like it at all, mainly because it suffered from all of the things that we've just been talking about. And I just cast it in the bin. When I say the bin, I mean in the cupboard of dead products and dead projects and things like that. But I thought, I'm sure if we make this better and more hi-fi, for want of a better word, we should be able to get something reasonably good out of it, because it uses the 5532, which one or two of you have noticed I've mentioned before. So it's basically a good product, but the peripheral components around it do horrible things to it. Just to recap slightly, the major problem with the preamp was there was way too much lift and cut, and it was bordering on 20 dB plus and 20 dB minus over the ranges, which is just ridiculous. If you then look at the second video, when I brought the product back to have a re-look at it, I modified it somewhat, and very easy modification, and I suggest you go back and have a look at these so what I'm saying now makes some kind of sense. Basically, I reduced the range of the tone controls. They now have a much less range, virtually no phase shift if you superimpose the input on the output, and even at sort of 30k the phase shift is just about noticeable, but not much goes on at 30k for music, so I don't think we have to worry about that. Anyway, that brings us up to date today. I've actually decided to adopt this preamp as a main preamp feeding my L12, because on most things the L12 has plenty of gain, but it does mean that often I'm operating it with the volume pot at about 3 o'clock, so there's not much left. So I thought a little bit of gain would be helpful, and if I've got some hi-fi tone controls, I'll tell you where it will be useful. I do quite a bit of Skyping, as I've got friends and relatives all over the world, and some people don't have, shall we say, the best equipment. And when they're Skyping, sometimes it's very heavy and bass heavy, and other times they use a telephone and it's very tinny. So if I can have tone controls where I can reduce the treble and or bass, admittedly this isn't a hi-fi reason for having one, but often you get a piece of music where it's excessively bass heavy or bass light. It's handy to be able to just tweak it just that little bit to make it more pleasurable. It moves away from hi-fi a little, but we like pleasure as much as hi-fi, don't we? This is my latest version of the 5532x2 preamp, which I featured previously. I've put it in a cabinet with a power supply and done a couple of other small mods that I want to tell you about, and I'm going to go into it in relative detail, so if you want to build one, I will give you enough information that you will be able to find the components and get the same sort of results. Now, this version uses a conventional mains transformer. I don't want to poke too much because it's actually switched on, but saying that, there's nothing live in here at all, no naked wires at all. This transformer comes from the usual suppliers at AliExpress. I'll put a link into the description to show you where I purchased them from. Many people sell these, so I'm not endorsing any particular supplier. But it's as simple as this. Mains in. Unfortunately, this particular transformer is only 220 volts in on the red wires, and the output, this particular one, is 15/015, hence the 3 wires. Now it's only rated at 100 milliamps, hence the size. You can see how small it is when I put it in my hand. And they are very cheap. Now don't let the very cheap put you off, because in a previous video I made a similar preamp using a switch mode power supply, and some people have reported problems with hum and buzz, and it's largely due to leakage on the switch mode power supply, because most switch mode power supplies, the secondary should be completely isolated from the primary of the circuitry, and they are sort of, but they do have a capacitor from the output to the input, which, although if you're lucky they are proper mains rated ones, but not always the case. So you can measure the output, and you can often find mains on it, not to the extent that you'll get electrocuted, but it's purely leakage of the capacitor. And when you're dealing with preamps, clearly leakage is a major problem, because you're dealing with very low levels, and that's the last thing you want. This transformer, along with others in the series, has the secondary on a completely separate part of the bobbin, so there is no danger of leakage capacitively to a degree, but much less than switch mode. So there is the biggest problem with most transformers is the primary is wound on top of the secondary, or vice versa. So you're relying on the insulation of the wire, or a bit of tape if you're lucky, to isolate live mains from your low voltage output. But with this kind of transformer with a split bobbin, they're not quite as efficient doing it this way. But from a safety point of view, I've tested this, and the maximum I can put on it is 2000 volts, and there's zero leakage. It's up in the hundreds of megohms, which is what you'd expect. Now, how you organize your own version of this is up to you. There is no power switch on this at all, simply because it will be connected to what do you call those blocks with multiple plugs on? Yeah, a block with multiple plugs, or multiple sockets to be precise. So when I finish working on the amplifiers or whatever, I just knock off one switch and everything connected to it has its power removed. So I haven't put a power switch on it, although I did think about it and realised there wasn't really a lot of room in this rather small box. It's a plastic box which came from a company in New Zealand called J-Car, which I think if you're in Australia you can also use these, but they're a fairly generic case that you can buy from millions of different places. So looking inside the box, the preamp is as modified on the previous video, but I've just done 2 other simple things on here. There used to be input sockets on here, and I couldn't really see any point in putting phonos into the sockets, so I've taken the wires straight from the top of the PCB to the input here, which you can just about see. The only other modification I've made is here. Now these were as supplied 4.7 microfarad, and they were electrolytics. Now I've put these capacitors in there instead, and I have to say personally I cannot honestly say that I can hear any difference, but theoretically an electrolytic is not a good capacitor to put in the signal path. Some people swear they can hear the difference, and it makes the difference between chalk and cheese. But I have to say, when I first put this together, I left electrolytic in this one and changed this capacitor and switched to mono and kept flipping between the two, and I have to say I genuinely could not detect any difference. Now the other point of contention are the 5532s. Some circuits you can tell the difference apart from measuring. I've explained on another video how you can test these to see if they are genuine. These particular ones are genuine. It's one of those things there where it's designed to be used with a genuine one, and anything that isn't genuine isn't as good. And generally the ones that aren't as good do measure not so well. The difference again is absolutely microscopic. In this case, it's up to you, but these are so cheap, why would you want to put a fake in there? So that's where we are, and the only other thing you can do is to replace the volume pot from a linear pot, which is supplied with the kit, to a logarithmic pot. And I haven't done that yet, although I am going to do so. Now, getting back to the transformer again, it is really, this one is 15-0-15 and is a little more than you need. You could use a 12-0-12 because you've got two 15-volt regulators here, but at 12 volts you are close to the sort of minimum you need to get good regulation. Saying that, because these transformers are made for 220 volts, I found the voltage on them quite high. I'll get my meter and I'll show you. We're on the 20 volts AC range, and let's have a look at what the input voltage is from the transformer. And this is on load, so it's 17.61, and of course negative on the other terminals. Well, not strictly negative because we're still on AC, but you can see for a 15-volt transformer, 17.6 volts is a little on the high side. Unless, of course, you happen to have 220 volts, then it'll be fine. If you're going to buy this, I would still go for the 12-0-12 because you will still find it's nearer the required voltage. But saying that, the current consumption is about 10 milliamps. So these regulators, even with that sort of input going into the circuitry, these remain cold. I can't feel any temperature rise on anything. The only thing that does get warm is the laminations on the transformer. The windings themselves are stone cold, but the efficiency of these small transformers is not as high as a bigger transformer. So you do get more losses in the core itself, than, if you like, the magnetization current. But it's not hot. It's not like you can spit on it and there's going to be steam coming off. This has been on now for about an hour, and you can see I can quite happily lay my fingers on there, and it's warm. It gets a little bit warmer with the lid on, which of course is completely sealed then, but it's something I don't think you need to worry about. It doesn't help the fact that you've got the transformer mounted on plastic. I don't know whether it's worth doing, is put a piece of aluminium along the bottom and to basically just spread the heat. But don't worry if you don't want to do that. You will not burst into flame. Well, it will not burst into flames. It's still very well, because normally, of course, a transformer would be mounted on something metal. Now, I mentioned earth loops earlier on, and it can be a major problem. But I've actually used a 2-core cable here, and there is no direct connection to earth whatsoever. And as there's no metal work, of course, I don't have to earth anything. You could possibly debate that the transformer itself should be earthed, and possibly so. If you've got a 3-core cable, just take the earth to the metalwork of the mounting bracket, and that won't cause an earth loop because it's not connected to anything else. As it stands at the moment, let's zoom out slightly, as Clive's always saying, this is the input sockets, and that goes to the DAC in my computer. Well, it does on this bench anyway while I'm testing, and goes in here. So there is no extra earth connection anywhere in this circuitry. The earth obviously has to go to the ground of the input socket, and the same with the output. You can see there's a link across there linking the two outputs. This is the output, and that's going into my amplifier on the bench. And there is absolutely zero hum. Now, you'd think with the transformer so close to this area that you get a field. Well, I suppose you do, but the transformer is so low powered that there's virtually, well, to me, undetectable spillage into the circuits. You will, of course, need screen cables like these are for the input and the output. Don't be tempted to just wire them, because then you are asking for hum, and you can almost guarantee you'll get hum. That's all I can say about it. It just happens to work and sounds really good. In fact, this is going into the other room presently after I finish confirming that everything on the bench is okay, and it will be part of my L12 HiFi. Now, I'm going to try and do something so you can hear the effect of the tone controls in this circuit. Now, I've tried with various bits of YouTube friendly music. It's not very effective to actually play it. So what I've decided to do is to put some white noise on with a flat frequency response going into the preamp, and then take the output directly into the camera here. And depending on how it works, I've put it in manual settings so you can hear the effects. I haven't actually done this yet, so I don't know if it's going to work, but I hope so. Now, bearing in mind, if you're listening to this on a telephone, you're not going to hear it as it should be. You need to be playing this through a decent pair of speakers. Otherwise, it's pointless, and I wouldn't even bother attempting to listen to it, because all you'll hear is, well, probably not a lot. I've done the test in the other room with the preamp without the camera involved, and you can very clearly hear the different levels in the white noise, and I think it's quite effective. But please don't judge it if you haven't got something to listen to it on. You might try headphones, but be careful. I've tried not to make it over loud or anything, but be careful. On a parting footnote, I just want to mention the LED for the on indication. Now, I've taken the supply from this off one of these capacitors. Now, I can't suggest a resistor value because it depends on how bright and what colour LED you actually choose. Now this is a green one, fairly obviously I think, and I've actually got a 61k resistor in series with the LED, and that's pulling about 2 milliamps and is more than bright enough, because these LEDs are reputedly rated at 20 milliamps, but with 20 milliamps going through it, it's going to use more power than the whole circuit. So it's only meant to be an on indicator, as you can see, nearly in focus. It actually looks brighter on here than it is in practice, but it's a start. If you've got a green LED, start with about 61k or something very similar, and just choose the brightness that suits you the most.